The quest for artificial general intelligence (AGI) has long been the stuff of science fiction, an intelligence that mirrors or even surpasses human intellect. But what if the true dawn of AGI isn't about writing poetry or philosophical debate, but something far more tangible, something deeply embedded in the digital DNA of AI itself? Welcome. Today we delve into a groundbreaking forecast, one that redefines AGI not as a distant, all-encompassing human mimic, but as a specific, measurable engineering feat, an AI system capable of autonomously improving its own code. Imagine an AI that can, even marginally, fix its own bugs, optimize its own software, or add small new features to its programming, all without a human engineer guiding each step. This is the threshold we're exploring. Why this definition? Because it's concrete. It's a milestone that current AI is already inching towards, a critical capability that could precede the broader, more philosophical notions of AGI. And the capacity for self-improvement? It's a cornerstone. It hints at a system that could accelerate its own development, potentially leading to a rapid escalation of capabilities, what some call an intelligence explosion or recursive self-improvement. Even small autonomous enhancements, compounding over time, could trigger substantial advancements. Part 1. The digital engine computational power. The story of AI is inextricably linked to the colossal growth in computing power. Since 2010, the computational muscle used for training significant AI models has been doubling, astoundingly, approximately every 5 months. That's an annual growth rate of 4.6 times. Simultaneously, the cost for this power has plummeted, halving roughly every 18 months. Think about that. Double the power for the same price, year after year. By 2022, the largest AI experiments were consuming around 10 to the power of 16 flops days, with this peak compute usage doubling every 3.4 months historically. But this hyper-exponential growth for the biggest experiments is hitting a wall. Projections show a dramatic slowdown within the next 5 to 10 years. Why? Because these computational demands are approaching a noticeable fraction of total global computing capacity. Unchecked, their cost would eclipse world GDP. Consider the energy. AI data centers are projected to need an extra 10 gigawatts in 2025 alone. By 2027, that could surge to 68 gigawatts, nearly doubling global data center power needs from 2022, comparable to California's entire 2022 power capacity. A single large AI training run could demand 1 gigawatt by 2028, potentially 8 gigawatts by 2030, the output of 8 nuclear reactors. Yet hardware innovation continues. Benchmarks like MLPerf show staggering gains, with Llama 270B inference performance doubling in just 1 year on median, and the best score 3.3 times faster. New chips like NVIDIA's B200 and Google's TPU Trillium push boundaries. But the system-level constraints of power and cost mean we're shifting from an era of brute force scaling to one where efficiency-driven progress is king. Indeed, the AI Index Report 2025 notes AI is becoming more efficient and affordable, citing a 280-fold drop in inference costs for GPT 3.5 level systems in just 2 years, and annual hardware energy efficiency gains of 40%. Even if spending on the biggest experiments moderates, overall AI performance, a mix of investment and effectiveness, is still tipped to double roughly every 6 months, thanks to software and hardware price-performance improvements. This path to AGI might rely less on singular massive training runs and more on continuous, efficient learning. Part 2. The Smart Code Algorithmic Advancement. If compute is the engine, algorithms are the intelligence at the helm. And here, progress is electrifying. On challenging benchmarks like MMMU, GPQA, and the software engineering benchmark SubUI Bench, AI model scores leaped by 18, 48, and even 67 percentage points respectively in a single year. But it's not just about raw scores, it's about efficiency. Between 2017 and 2021, the dollar cost to hit 93% accuracy on ImageNet classification plummeted 223-fold. This far outpaced hardware cost reductions, highlighting the sheer power of smarter algorithms. This has led to concepts like Williams' Law, suggesting AI capabilities can keep advancing exponentially through better model design, even if hardware progress slows. From 2012 to 2019, the compute needed for fixed ImageNet accuracy dropped 44-fold, mostly due to algorithms. Some estimate algorithmic efficiency itself is doubling every 9 to 16 months. Recent breakthroughs distinguish between compute-dependent innovations, like the transformer architecture, and compute-independent ones like flash attention or rope, which boost efficiency across the board. Prompting techniques like chain of draft can achieve similar accuracy to more intensive methods using only about 7.6% of the tokens, a 13-fold efficiency gain. This is crucial. If physical compute scaling faces limits, smarter software becomes the main engine. AI is also learning more efficiently. Self-supervised learning and foundation models can be fine-tuned for myriad tasks with minimal specific data. Meta-learning, learning to learn, allows AIs to adapt faster. And AI isn't just recognizing patterns, it's tackling complex problem-solving and reasoning. OpenAI is even exploring models that perform multiple internal reasoning steps, hidden thinking tokens, to arrive at solutions. Empirically, the complexity of tasks AI can reliably complete, measured in the time it would take human experts, has been doubling approximately every 7 months for the past 6 years. This includes software engineering. If this trend holds, within 2 to 4 years, AI could autonomously handle software tasks that currently take humans days or weeks. Part 3. The Spark of Autonomy. AI's Path to Self-Improvement. This brings us to the heart of our AGI definition, an AI that can marginally autonomously improve its own code. Today, tools like GitHub Copilot already generate code and identify bugs, boosting developer productivity by over 55%. DeepMind's AlphaCode autonomously crafts solutions to competitive programming problems. But the real frontier is AI systems enhancing themselves. The latter framework allows LLMs to autonomously improve problem solving by generating simpler versions of complex problems and learning from them. A Llama 3 billion model went from 1% to 82% accuracy on undergraduate math integration problems using Ladder. A 7 billion parameter model achieved 73% on the challenging MIT Integration B exam, all through self-guided learning. OpenAI's reported O1 model uses reinforcement learning to refine its reasoning. The self-taught reasoner, or STAR, learns from its own generated chains of thought. Systems using DSPI can incorporate human feedback to improve future outputs, with AI-generated emails matching human quality 80% of the time. And theoretical models like noise-to-meaning recursive self-improvement suggest that an AI feeding its own outputs back as inputs can experience unbounded growth in internal complexity. Operationalizing marginally autonomous improvement could mean an AI autonomously identifying and patching its own bugs, refactoring code for efficiency, or fine-tuning its own modules. The challenge? Ensuring these changes are beneficial and safe, a task that itself might require AI-driven verification. Part 4. The Crystal Ball, Synthesizing the Forecast. So, when might this self-improving AGI arrive? While raw compute growth for the largest experiments faces headwinds, the ongoing improvements in hardware price performance and, crucially, algorithmic efficiency mean effective compute will continue to grow substantially. AI is thinking smarter, not just harder. Expert forecasts are converging and timelines are shortening. AI Impact's 2023 survey pointed to a 50% chance of high-level machine intelligence by 2047, down from 2059 a year earlier. A larger 2023 survey also gave a 50% chance of human-level AI by 2047, with a 10% chance by 2027, a significant revision from around 2060 in 2022. Metaculus, a prediction platform, shows a median for weekly general AI at 2027, and for first general AI system at 2031. This latter forecast shifted from 2041 to 2031 in just 1 year. OpenAI's Sam Altman has speculated AGI is plausible in the next 4 to 5 years. Anthropic's Dario Amodei gave 50% odds within 2 to 3 years as of 2023. Based on these trends, we can outline 3 scenarios for AGI defined by autonomous code self-improvement. Scenario 1, accelerated progress. A 20% probability. This sees AGI by 2027 to 2029. It assumes rapid breakthroughs in self-improvement algorithms, aligning with aggressive expert forecasts and the rapid doubling of AI's autonomous task completion ability. Scenario 2, expected progress, a 50% probability. This is our most likely window AGI by 2030 to 2034. This assumes current strong trends persist with capabilities emerging gradually. This aligns well with median Metaculus forecasts. Scenario 3, decelerated progress, a 30% probability. AGI arrives between 2035 to 2045 or later. This accounts for unforeseen bottlenecks or the immense difficulty in achieving reliable, safe self-improvement. The strongest probability mass falls between 2030 and 2034. Our narrower definition code, self-improvement, makes these earlier timelines more plausible than those for all-encompassing human-level AGI. Of course, wildcards exist. Unforeseen algorithmic leaps, geopolitical factors, or fundamental limits could shift these timelines dramatically. Conclusion: the dawn of a new era? The evidence points to a significant probability of an AGI, capable of marginally improving its own code, arriving within the next 1 to 2 decades, most likely between 2030 and 2034. The emergence of such an AI marks a profound inflection point. It's AI transitioning from a human-crafted tool to an active participant in its own evolution. This could drastically accelerate AI development across all fields. But it also brings monumental safety and alignment challenges. How do we verify, control, and trust an AI that can rewrite itself? We must proactively monitor key indicators: algorithmic efficiency, benchmarks for self-improvement, AI's agentic capabilities in complex tasks, and breakthroughs in recursive self-improvement research. The coming years are critical. The journey to self-improving AI is underway, and its arrival will reshape our world. The question is no longer if, but when and how we prepare. Outro music swells.